Day 20 of cracking 500 AI and data science interview questions challenge. 5 questions a day, 100 days. One step closer to your dream job. If you are new here, don't forget to check out the playlist. You might have missed some key questions that will be important cracking your next interview. Great data scientists don't just build models, they build systems that last. Always ask how will the solution behave 6 months from now with new data and evolving business needs. Sustainability matters as much as accuracy. Today, we will focus on feature importance, bias in AI, explainability, and a couple of practical coding tasks to sharpen your fundamentals. How do you explain feature importance in machine learning? This is the first question. Feature importance tells us which input variables most influence the predictions of a model. For example, in decision trees, importance comes from how much a feature reduces impurity. In linear models, coefficients directly reflect impact size. In black box models, we use sharp or line to assign contribution values to each feature. In a credit scoring model, income and repayment history might be top features, while browser type has little weight. Explaining importance helps stakeholders trust and validate the model. What is bias in AI and how do you mitigate it? Bias in AI happens when models make systematically unfair predictions due to skewed training data or flawed assumptions. For instance, a facial recognition system trained mostly on lighter skin faces may misclassify darker skin individuals. Here is a way to mitigate it. Audit data sets for representativeness. Use fairness metrics, equal opportunity, demographic parity. Resample or reweight underrepresented classes. Involve diverse stakeholders in model evaluation. Bias is not just a technical issue, it is an ethical one that can damage trust and lead to regularity risks.
What is the difference between global explainability and local explainability? Think of global explainability as understanding the forest and local explainability as looking closely at a single tree. When we talk about explainability in machine learning, we mean answering the question why did the model make this prediction? So, for this process, we have two levels global explainability and local explainability. In global explainability, this looks at the model as a whole. It answers across all data what features generally matter the most. For example, let's consider a basic machine learning model of predicting customer churn. Global explainability here might tell us that contract length, monthly charges, and number of support calls are the most influential features overall. Think of it as a big picture view of how the model works. The second level is local explainability. This focuses on one single prediction. It answers for the specific customer why did the model predict churn or not. Suppose the model predicts a particular customer will churn. Local explainability could show that this happened because they had 5 recent support calls and a high mobile monthly bill despite being a long term customer. It is like zooming into one data point and explaining the decision just for that case. Tools like Sharp and Lime help us calculate both. They break down predictions into contributions of each feature. Find the most common element in a list using Python. So for this purpose, what you have to do is just by using counter of numbers. It can count frequency of each elements. Followed by that, you can use dot most common inside which you stored this counter function, right? So it gives the most frequent one. And here you are specifying the index 0 and 0, which extracts just the element, not its count. So as an output, you will be getting most common element as 4. How do you reverse a string in Python? In Python, string supports slicing with start, end, and step operations. So here just by specifying one at the position of step, which means start to end, but step backwards. So it prints the string reversed. If I give a string as artificial intelligence, after reversing it, it will print by starting with E and it ends with A. Here's your day 20 dose of insight. Explainability is not just a technical add on, it is a bridge between AI systems and the people who rely on them. Global explainability shows you the big picture, the common drivers across your whole data set. Local explainability zooms in on individual cases and builds trust by answering why me for each prediction. As a data scientist, your job is not just to deliver accuracy, it is to deliver clarity. A model that can be explained is a model that won't be trusted. Always think about how you would explain your model to both a CEO and to an end user because trust is what makes AI real in the world.